So I have an agenda for the demo today. There are a few things that I want to show. So I'll go over how we orchestrate Sonic-based AI fabric using Sonic. Then I'll also show how we use the NVIDIA AIR reference architecture to orchestrate the fabric. I'll also go over some data operations. So if you want to change any configuration, you want to do backups and restores, how you do that. And I'll also show what inventory we collect, how we do anomaly detection with the inbuilt rule engine that we have, and how you can integrate all the alerting and notification with customer tools like Zendesk, ServiceNow, or Slack. And obviously, between I'll have some questions also. So I'll start with Sonic-based AI fabric first. So I have a small video. I'll be jumping in between videos and a live demo. So, second, okay. So if you look at the topology here, I have 2 spines, 3 leaves. Those are Broadcom-based switches running Sonic right now. For the orchestration itself, on Sonic devices, we have a small agent called FMCLI that enables us and the controller to actually talk to the switches directly in an industry standard CLI. I'll show how the CLI looks like, so you don't have to learn a new CLI to use Sonic in your network right now. So you go to configurations, and how you actually orchestrate is, we have a simple intent-based YAML. Once again, looks something like this, wherein you define your network. So your inventory, how many spines, how many super spines, leaves, and TORs you have, how they are actually connected. So we have a plan to integrate LLDP here, but LLDP can sometimes be, you want a source of truth right now. So here you just provide how the switches are actually physically connected. So you provide your inventory, the physical connections that they have right now, and what parameters you want to configure. Do you want to configure BGP? Do you want to configure BGP unnumbered? How are the physical interfaces looks like? What AS numbers you want to use for, and various other parameters. So if you look at the YAML here, we are talking about the whole fabric and not just per switch. So you define the intent for the whole fabric, whether it's a small deployment, large deployment, and you basically say what AS numbers you want to use for the super spine, for the leaves, TORs, what IP pools you want to use, and various other parameters.
Can I ask a quick question? All right, so is this, do you fill this information in the YAML script, or do you have a GUI that you fill it in on?
We have a GUI. I'll come to that also. We expect our customers for a large deployment to edit the YAML file, and for that, we have an open source repo where we have 70 plus tested templates. And if you go here, if you have a normal IP cross deployments, we have a template for you. If you have multi-tenancy with VXLAN, we have a template for you. So what we actually expect is, you go here, you take this YAML, you edit it for your specific inventory, for your specific connections. You fill out the IP addresses, your username and passwords. We also have all the QoS configurations, all the various things that you need for the actual Sonic AI fabric. All your schedulers, your PFC, if you want to enable ECN, the schedule, everything here. So we expect you to download this, edit it, and basically orchestrate it. Yeah. So you get this, you put it into the system, and that does the orchestration for you. So when you start the orchestration with all the QoS and all the parameters that you have, we do 2 kinds of validation. One is config validation, wherein when we are actually configuring the switch, we look for any errors that might be thrown out. That gets the status into a failed state, and we stop for that particular node. The orchestration is stopped if it's a failure. We also do operational checks. So we are also checking for control plane. We are also checking for data paths. So if we have, let's say, 3 leaves right now, and so what it will do once, it will check all the data paths from leaf 1 to leaf 2, leaf 1 to leaf 3. All the data paths that I have, it will run show commands to see if everything is as it should be. It will also do ping test from all the leaves to all the other leaves, so that we know the thing that we want to configure, it's actually reachable from here. And one thing I want to show is, while you are doing all this orchestration, you can also look at the running logs. So this is one of my live instances that I have. I'll come to the topology later. What I want to show now is, you can look at the running logs. So you can come here while this is being orchestrated. So everything that is being done on the switch, you can come and view live. So if you look at the CLI here, right, we go into our FM CLI, basically the agent, and then the CLI is industry standard. So you go into configuration terminal, you configure your interface, If you want to configure BGP, so the UI is industry standard. You don't have to learn anything new. So we are doing show checks. We are doing checks for the BGP itself. If everything is up, we are checking the neighbors. What is the state of the neighbors? And we are also doing at the end ping test for each of the neighbors, or all my hosts, all the routes that I have, are they actually reachable?
Quick question.
Yes.
Brian Martin, Signal 65. While you're doing that configuration check, what happens if you find miswired cables?
Yeah, so so configuration will pass because configuration was not an issue. You were able to configure the interface, you were able to configure the BGP, but the BGP will not come up because the wires are messed up, right? So on the status here, once again, on the status here, it will actually show when it fails, it will actually show the BGP between leaf 1 and leaf 2 or leaf 1 and spine 1 did not come up because the interfaces maybe are not up, or the interface is up but the BGP did not come up. Or at earlier stage, BGP is up, interface is up, but we are not able to ping it for some reason. So it will clearly show that message here as a pop-up, and you can then go down and look at the whole logs. And for that matter, we have a connect button here. So let's say you see this issue, something failed, you want to connect directly from here. So what you can do is you can click on this connect button. It will take you to your UI. You can connect to the switch directly via SSH, or if you have a console server, you can put the creds for the console server, and that will take you to the actual SSH session for that switch. So let me check if I have a failed session right now. This is one of our second that I have. Okay, so something failed here. So we are orchestrating topology, and it's saying when I try to ping the host from leaf 1 or leaf 2, something failed. So here it shows we are trying to ping 40.005 from source 10.10.10.2 with packets, and this failed. I can go and look at the logs here, and it will basically show me everything passed, but the last step of the configurations is showing BGP. Okay, so BGP here is stuck inactive. That's why that is not coming up. Maybe now the wire is messed up, but it clearly shows you that something that the intent was for the configuration that did not happen. So we are marking it as failed. And for that particular node, the orchestration stops, but it continues for your other host. So you can go back, look at that specific node to figure out why that failed.
Okay, so I'm confused. Was that an expected failure or an unexpected failure on your behalf?
This is unexpected.
Oh.
Because we are expecting source of truth, and we are expecting that all the information that you provide in the YAML, the interfaces that are directly connected, we are expecting that it has to be source of truth. That is why we are not going with LLDP right now. We have a plan to basically have LLDP, but we are still testing it internally. We are relying on you to provide the actual source of truth for us right now.
Okay, so you didn't construct that. I'm just trying to understand. You didn't construct that in the demo, or you expected to see that failure. I'm confused.
Oh, no. Oh, so the failure, I'm just trying to show, this is another demo that I have, another instance. Okay. This is just, I'm trying to show that if it fails, we will show you.
Excuse me, another question. We have seen in the YAML the credentials.
Yes.
Is there a way to put the credentials outside the YAML? So are you implementing something like...
Yes. We have requests from customers who use LLDP or LDAP or something else, right? We do right now per customer, because we see every deployment is a bit different. So we do support it, but right now on the public GA that we have, it's there in the YAML, but we do support it. But it's right now per customer basis for right now for this current release.
Okay, gotcha.
Yeah. Okay. So any more questions for a Sonic-based AI fabric? So I'll move on to NVIDIA-based orchestration, how we do that. So if you look here, based on NVIDIA AIR 1.3.0, the reference architecture, we design your YAML intent. So we take the input as the number of GPUs you want to use in the AI fabric, the first IP octet you want to use, and based on this input, we actually construct the YAML for you. What we can also do is, we construct the YAML for your physical real topology. What we can also do is we can create NVIDIA AIR dot files. So rather than actually going and deploying a physical topology, you can create kind of a digital twin with NVIDIA AIR beforehand to test out if everything is working okay, working fine, and then go ahead with the actual real deployment. What we can also do is the server itself can behave as a ZTP, DHCP, or NTP server, but obviously you can use your own. We also had an idea here for the network design itself. Rather than taking input as the number of GPUs, maybe we can take the scalable units as input, how many scalable units you want here, but we are still deciding on the UI part. What input would be best for the users to to make it easier. So the UI is not ready here yet. This part will be, when we have a GA, this part will be skipped. What eventually is happening is, we take the input as a number of GPUs, the IP subnet that you want to use, and we are creating this YAML internally. This will all be internally in the GA release. And basically, I'm just copy pasting it here because we don't have the UI yet. So I have my YAML intent here. So this is all running on Spectrum-X platform. The Spectrum-X platform, we are doing agentless, so you don't have to install any agents there. And while it does that, it auto discovers it based on the host name that you have. So it goes there, passes the YAML for you, checks, do an initial validation. If all the nodes that you're mentioning or all the parameters that you're mentioning here are they actually valid? Does that and starts all the orchestration in parallel. So this not only orchestrates your switches, but also the compute nodes, because we want to have a route back to reach out to the network. So we also orchestrate the actual compute nodes itself. And this topology right now, this I'm running in NVIDIA AIR. So orchestration has started. While this goes on, this will do all its validation checks, configuration checks. And while this does that, so this is the topology that I have in NVIDIA AIR right now. And if you look at it, I have an out-of-band management switch that I have once. So the controller itself is running in NVIDIA AIR for this specific demo as an OVA sitting here and reaching all the switches over out-of-band. So we have 4 spines here and 8 leaves, and with 4 actual compute nodes down below.
Ravi, for my fellow network folks who aren't familiar with NVIDIA stuff, what is NVIDIA AIR?
So it's a virtual environment. So you might be aware of GNS3, right? That runs locally on your. So it's
yes, GNS3, yes.
Yeah, sorry.
Yeah.
So it's an environment, online cloud environment, where you can go and simulate your topology. So if you have an intent to simulate, let's say, 1 scalable unit, 2 spines, 4 leaves, and you want to test it out before actually going and buying the hardware, actually configuring your physical switches, you can do that here. And the configuration, the good part is all the configuration that is being done here, it's identical 1-to-1 with the physical actual deployment. So that is why we have it as part of our deployment also. So you make the YAML intent, make the dot file, configure this topology here, and that basically gives you your real world kind of a scenario where the configuration is also same, the behavior is same, everything is same.
Cool.
Yeah.
Thank you.
Yeah, quick. And I know we're obviously so much into this every day. The NVIDIA AIR is basically simulation cloud that NVIDIA runs, a cloud simulation environment that they have, where you can instantiate NVIDIA devices as a digital twin, right? And so you really can simulate network fabrics, including the servers and the NICs, right? And so this is very, very helpful when you design a network. You basically put all the configuration together, you push it, and you instantiate it like a real topology, but it's virtual, right? Not physical devices in NVIDIA AIR. Then we use once our tool to basically validate that all the links up, because the cloud environment is like a real digital twin of what a real network would be. And you can do the same thing. I can check all my interfaces. I can check what he just described for Sonic, right? In the NVIDIA world, this is going to be running Cumulus, but OS, right? Same thing. But you can basically validate all the switch configuration, that everything is reachable, all the things you can do in NVIDIA AIR. And when you're happy with that, right, and you're going to see it on the screen, that's why the screen looks the same. That's in our tool. We're using NVIDIA AIR as the backend to basically probe, instantiate, probe, happy, and now I can go and deploy. So that's maybe a little bit more going slower.
Thank you.
Yeah, no worries. Go ahead.
Thank you both.
So it does all the configurations. Basically, it's a large fabric, so we have everything done. Basically, it waits for everything to be completed. And one more thing I'd like to show now is, if I go back to my live setup, I have this, right? So for day 2 operations, we can also do, we can look at the intent, what the YAML that you programmed, what the intent of the configurations was. So for this specific topology that I have here, my intent was I wanted to create some VLANs on some leaf switches with this IP subnet, supporting 64 hosts, and this is the IP range that I wanted on it. And the controller designed this configuration that is actually pushed for this intent to happen. right? And if you look at the CLI, right, it's industry standard. It's easy to understand, easy to configure. What we can also do is we can also do config compares. So if you are applying configuration and you want to look at what I applied and what is actually running on the switch right now, we can do that. Because we also do backups and restores. We can also look at the last happy baseline backup that I have. So we can do that. So for the intent, I wanted to apply this. This is what the controller thinks that should be applied, but maybe somebody went ahead and changed something in the background. So we see the router ID is now changed. We see VLANs are now changed. So you can clearly see the intent was this. This is what we generated, but something happened in the background, making the difference, right? So what we can do is, rather than looking at the running configuration, when the orchestration is successful, we also do a happy baseline. So we take a backup automatically at that time. So what we can do is, we can look at that backup at that time. What was the intent? So we see the intent and the backup at that particular time when the actual orchestration was completed. This looks good, but something happened in the background. So this gives you a clear idea of if somebody is changing any configuration in your fabric. What we can also do is, if you are looking at running configuration, we can basically compare configurations on what happened. We can compare configuration between different switches. What is running on leaf A? What is running on leaf B? We can do comparison between them also. So all the running configuration is actually polled in real time. So agent contacts the agent. Sorry, the controller contacts the agent, gets the real time whatever is running on the switch, and we can basically compare here.
Maybe to step in, you probably, I don't know if you ever have done this, you probably wonder why this is actually matter. Let me step out of the picture here for the gentleman in Prague. As if you do like modeling type template-driven deployments, the configuration tend to be the same except the IP numbering, right? And so what this allows you to do is that any drift happening over time, right? If somebody deployed this, everything is happy, and then doing normal operations, maybe somebody configured port up, port down, and you can easily configure leaf to leaf when you know they should be the same and they are not, right? So that's one, right? Between same type of devices, that's comparing two devices. The other one is you had a golden configuration when you pushed it and something drifted on that same device over time. Now, I had a backup. I know that was a good configuration. The current one is this. Tell me what's the difference, right? And then obviously you can use this in normal networking to roll back if you need to, right? There are a lot of different scenarios, but the point really, if you look here, it's very, very easy to do configuration comparison on a per device basis, and then just adjust, right? And this is going back where when we started this as it was a pure monitoring tool, it becomes really how do I operationalize anything that has to do with configuration and templating. And just to give some context. So yeah, keep going. I have more, but okay. I'm pretty sure you have more questions.
Yeah. What we can also do is do day two operations. So let's say you have orchestrated your fabric. Now you want to do a VLAN change. You want to maybe add a network, add a VLAN. So we can do that. So for any switch, you go to NetOps. It gets your current running configuration on the switch, and you can basically pull it here and make a change. So let's say I want to change the router ID, right? I want to add another VLAN now. So you can make the change directly here and click on apply. And basically what the controller does is it realizes that we are adding a VLAN and changing the IP. So it only does these two changes on the actual device. You don't have to reorchestrate your whole fabric here. So we can do that also. And last, we can do obviously backups and restore. So you can give it a tag, some tag, start the backup. And when you have the backup, we can store multiple backups, and you can do restores for that particular switches or your fabric directly from here. Any questions?
At the risk of asking a heretical question, this tool looks phenomenal for network engineers.
Yep.
In simplifying their day-to-day task. What about the accidental network engineer? And you could tell me in a deployment this size that doesn't exist. But what about the accidental engineer that knows enough to get himself in trouble, or herself to get in trouble, but not enough to understand the edits you just made and putting those VLANs in the right place?
Yeah, you would. Go ahead.
So We control it and in a few ways. One is we have different roles you can assign for the UI itself, wherein you have admin rights for a user. You have where you can create telemetry, create notification, look at all the alerts, and point them back to your Zendesk or Servin desk so that some agent can look at it. Or you have view-only access here. So basically, how I think that is how. But when you actually do a VLAN configuration, and let's say you enter a wrong syntax or something, it will tell you that the syntax that you are entering, while it is orchestrating, it will tell you that syntax that you are entering, it's wrong. It's not going to actually go and configure it. So the UI will show that there is a difference between the running config and the config that you're trying to do. But if the configuration is wrong, it's not going to push it. It's going to say the syntax is wrong, or the thing that you're trying to do, it's not correct.
Okay. And this is where Copilot might come in the future and let me say what I want to happen, and you'll translate it to the right words.
Yeah.
Yes.
Yeah. Let me expand on this. So there are two things. You're absolutely right. This tool is very, very powerful from if you had a operation support for the network, you literally have control over everything, right? You can literally change the device configuration line by line if you want. To your point, that's not what you want everyone to do. So we do have the multi-role capability where you say, hey, if your user have this role, you cannot change. You can only view, or there's certain things you can only do. So that's one way to adjust this. The second one is what we showed was templating, right? Where you saw when you did the NVIDIA scenario, all you have to enter is literally three things, right? Tell me how many GPUs you want, what's the starting subnet for the NICs, and that's it, right? You don't have to know anything, right? You don't have to know how to, because the number of GPUs will generate how many switches do you need. It will tell you automatically what the topology is. It will automatically tell you the IP numbering on every port on these switches. And the configurations automatically, out of all of this input, automatically generated. And then it's just applied, simulated, and you don't have to, you can see it, but you don't have to know, right? You can if you want to, but you don't have to. So that's the other extreme, right? This is what we see where a lot of vendors go with reference architecture validated designs, right? What Ravi described. And so we have this for the NVIDIA Spectrum-X reference architecture, but we also have, and this was the comment to the YAML file, which is a public Git hub repo that we have, where we're actually having YAML files for different device configuration that are basically pre-populated with the right settings. And then all you need to do is adjust, right? Because we created them, let's say you want a 4-leaf 2-spine topology. If you say, hey, I have 4 servers, I need 6 leaves and 2 spines. You just need to copy the 2-leaf configuration over, adjust the numberings, and you're done, right? So that's more the template driven, where you reduce the amount of detailed knowledge you need to have, right? But as an operator, once it's deployed, you want to have full visibility, right? If you have to troubleshoot, you need to be able to go to every individual device. And so we have both of these modes.
Right. Yeah.
And then the third one you touched on is the Copilot, which we don't demo, but clearly all the data is available through an API, right? What we just show is config 1, config 2. You could literally type the question saying, hey, I want to know the config differences between the backup that was taken on day 2 and day 3, and please summarize this for me. And you basically get a nice little written summary what the differences were. So that's why I personally think a lot of this is going to go, just to make it simpler and faster instead of trying to figure out staring at a screen like what you guys did.
I saw the template for the NVIDIA configuration. Yeah. You also have a template for Sonic environments as well?
Yeah.
All this, everything is it's Sonic.
We started off with Sonic, and we're adding, so if you think about Cumulus as a very close, and I need to be careful the way I word it, but it's same roots as Sonic. Right, so what we do, all this sampling, all we do for Sonic, you can do easily apply to Cumulus environments, right? And it's important, right? The reason why we have both is NVIDIA supports on their Spectrum switches, Cumulus as well as Sonic. So we will give customer the flexibility. If you want to deploy NVIDIA or Cumulus, we can do this. If you want to deploy on a GPU side Cumulus and on the front end for whatever reason you want Sonic, we can do this. We can give you both with the same tool. And then obviously you can use any other switch that runs Sonic on the front end. You probably, if you caught what we had, this was there was a real lab network that is running there. So I'm actually amazed. Ravi's like, when you went from the video to the real network, this is a real running lab network. As you see, we have Cisco devices running Sonic in there. We have Acton devices running Sonic in there. Pretty much every major hardware in there. you can run Sonic on these days. And so we will have that.
Can I use these, so it's I've defined a configuration. Can I use it like a defined state where I compare what's actually happening out there to what I specified originally?
Yeah.
Would that be a regular feature, something that Copilot could help me with?
Both. So you want to go back to compare configs.
Yeah.
You basically can use your original, let's say you created your original intent, and we use a YAML file right now, but you can pull it from wherever you're going to get it, right?
Yep.
And saying, hey, this is my config 0, day 0, right? That's intent config. And then you can pull the actual one and say compare. This is basically, you see it here. And now either you're really a geek and you look and say, oh yeah, I'm very comfortable with this. Or you're saying, hey, this is like, because these configs can be very long, right? Now this is where Copilot can help, right? And you basically just log into Copilot and saying, please compare these two configs and summarize for the differences. Both of these options are there.
Thank you.
Yeah.
Okay. So last thing I want to cover is how you can monitor this fabric. So when it comes to monitoring, we have a bottoms-up approach. So Sonic, we started once with Sonic. Right now we support 300 plus unique matrices. And if you look at it, once was originally built as a support tool for the network engineers, right? And when you have an issue or an error, we want to be able to find all the matrices that we have very quickly. So this is how we started as a support tool. So right now, we support end-to-end monitoring with network switches, servers, NICs, and GPUs. We support Rocky telemetry, whether it's utilization, counters, queues, drop, PFC, EC, and everything. We also do GPU metrics per GPU metrics for health, performance, utilization. And obviously, we have alerting and integration with tools like Zendesk, ServiceNow, Slacks. Right. So for the actual compute itself on the server, we can get GPU inventory, GPU health, and basically health of the server itself, plus all the GPUs that are running on the server, we can get all that. And for the switch metrics, we have for the AI specifically for the AI, we can get the Rocky configuration, all the maps, schedulers, double configurations that are actually running on the switch right now, and we can get all the counters associated with it. So I'll show that on the live demo itself. So this is kind of the landing page that we have right now. And if you look at, we have different platforms running Sonic, and we have all these different ASICs in a single multi-vendor, multi-hardware SKU controller. You have the visibility here. We have different views that you can look at this topology at. We also have AIML view. But what I'll focus is we can go to traffics to filter out all the QoS, basically the AI-driven devices. We can say only show me PFC-enabled devices, and on that only show me all the interfaces that actually have the QoS configuration for the AI fabric to actually work. So this shows me these are all your interfaces. So I can go to that particular interfaces, look at basic things, in and out packets, the utilization, the discards, and everything. I can go to advanced to look at frame level telemetry. I can look at unique queue packets for all my queues, the queue drops. I also have visibility for my bump traffic.
Quick question.
Yes.
Is there a way to export this data, or are you integrating that with third-party tools, or?
Not right now. No, not right now.
No.
But I think so. You can, the agent itself, the one telemetry agent that sits on the switch, it is gRPC based, GNMA gRPC based. So if you have a collector that can talk GNMA gRPC, you can probably poll directly. Because rather than using our GUI, you can use your GUI and talk to our agent. So that works.
Yeah.
So for the obviously you have the Rocky telemetry here for this specific interface. What are all my DSCP mappings, WRAD profiles, schedulers? If I have PFC enabled, if I have Watchdog enabled, what are my packets? So is it normal traffic, or do I have any Rocky specific traffic here? So you can visualize that also. All your PFC counters, all your queue drop, if you have any congestion notification packet for which queues, you can look at that. And all this data is visible for a window of 1 to a maximum of 2 weeks. For data older than 2 weeks, we have connectors for data lake, so you can push it to a cloud or store it somewhere else if you want to do analytics on top of it. But the UI itself, we do 1 hour to 2 weeks. We also have health of your fabric. So you can look at CPU, memory, and all the basic telemetry, right? We can also do capacity, so we can look at the ASIC. We can find out how many, so for the ACL itself, how many ACLs it can run, what is the current utilization. Same thing for IPv4 routes, IPv6 routes. So you can look at how my ASIC is actually visualized. How much?
When you say the ASIC, you don't mean the GPU.
No, we do the GPU as well as the
network ASIC.
Yeah.
Yes.
We can do both. So I'll come to the GPU part, but this is specifically on the switches right now. So the ASIC.
Right.
And obviously we have link level telemetry and we have protocols. So we can look at BGP, the show IP BGP kind of in a GUI format. We have LACP, MCLAG. For the AI fabric itself, we have QoS. So you can come here, look at what is actually active on what interfaces. Come here for details. And if you come and click on any of this, it will show you the actual configuration that it pulled. So these are all my queues that I have right now, all the mappings, my WRED ECN profiles, the schedulers that I have, and if I have watchdog enabled and what I'm doing with that.
And the GPU stats are coming from a host agent, or
yes, for a server running GPU, we have an agent, a small lightweight agent that you can put there. But for the Cumulus, the Spectrum-X platform itself, it's agentless. I think we are almost out of time, so I'll quickly show. We have GPU level telemetry here, so the number of hosts you have, the number of GPUs you're running. We show the all basic telemetry about your GPU memory. You can also look at per GPU. And with all this telemetry that we have, the last thing I want to show is we can create some rules. So we have an inbuilt anomaly detection system wherein you can come in and say, I want to create a rule for GPU utilization. We have per device, per interface, many things, and per server, obviously, right? So I will say I want to create a notification when the GPU utilization average for the last 10 minutes is greater than or equal to, let's say, 70%. Show a warning threshold, critical for 90, and send me a Slack message. Whenever this happens, send me a Slack message. And what I can also say is, you can also raise a Zendesk ticket directly from here. But what I will say is, if raise a Zendesk ticket only if the critical threshold is actually breached, and send me a weekly digest. So what happened for the week? How many notifications? What kind of notifications did I have? So summary of all the alerts that happened for the past week, you get it as a weekly digest on your Slack. And because you don't want to get annoyed, so we have a control here. So send me a Slack notification only once for every 1 hour, no matter if the alert keeps coming. So you don't want to be annoyed. So we have that. And we also have control over, stop after 5 times. So you send the notification 5 times, stop after that, I'll take a look. And you have some payload. So here you can write custom debug steps that you want to see. And we can basically come here and look at the alerts.
do you have a set of curated rules, like a starter kit?
Yes. Okay. That comes pre-enabled, and this is what the payload looks like. So this is what you'll get in the Zendesk, or if you raise a Zendesk ticket or Slack notification. So you have what happened, when it happened, where it happened, and how to actually dynamically reach there.